Rational expressions. Let's start out by factoring two expressions that you've already learned how to do. So the first one, factoring by grouping. 2x cubed plus 3x squared. I can pull out an x squared. In parentheses would leave me 2x plus 3. I'm going to copy and paste just like I have on a computer, a 2x plus 3 in back, and put a really light question mark. What times 2x is negative 8x? The answer is negative 4. And is negative 4 times 3 negative 12? It is. Now this front half and this back half both have a 2x plus 3. In front of the front half is an x squared, and in front of the parentheses in the back is a minus 4. Most students make the mistake of wanting to stop here, but you can go another step further. X squared minus 4 breaks into x plus 2 and x minus 2. Factoring this one. Okay, this is going to be a difference of cubes. 2, 2, 2, x, 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 and 5, 5, 5. Bring down one of the 2's and x's and one of the 5's and the symbol that was given in the previous in the beginning problem. 2 times 2 is 4 and an x squared. 5 times 5 is 25. Okay, in the back it will always be addition. If this is subtraction, then in this position we'll have additions. Opposite signs, and how do you achieve this answer? 2x times 5 is 10x. Those are your two review problems. Okay, now taking notes, the next four problems are going to use 3 steps. Please write this down. We will first factor, and then we're going to identify the excluded values. And I'll explain that more in just a bit. And then the last thing that we're going to do is we're going to cancel out to simplify our final answer. So talking about excluded values, when you think of a fraction, fractions can look like this, and they can even look like this, but what they can't look like is they cannot look like some number over 0. You can never have 0 on the bottom and the denominator position, or you'd be breaking a math rule. So excluded values means what would x be that would create a denominator that's equal to 0? Okay, let's start with number 7. So how I'm going to do this is I'm going to leave room right here to write my excluded values. And I'm going to leave room over here for my final answer. I'm going to show all of my work off to the left. So here we go. What multiplies to give you 60 and combines to give you negative 17? What multiplies to equal 60 and combines to give you negative 17? So here we go. 160, no. 230, no. 320, 415, 5 and 12. So x subtract 5 and x subtract 12. Now don't forget, in a hurry here, don't forget about taking the leading coefficient, which is a 6, and dividing by each term here. And I like to kind of not show all my work if it's not necessary. So over here again is my final answer. I know that 5 over 6 does not reduce, so over here I get to push the 6 up, and it's 6x minus 5, and 12 divided by 6 is 2, so x minus 2. I'm done with the numerator of the first fraction. Now the denominator is just the term x plus 4. It's not x and then a plus sign and a 4. It's like x plus 4. It's kind of like this is the girlfriend, and wherever the girlfriend is, the boyfriend follows regardless, okay? It's that person. We don't go anywhere. X doesn't go anywhere without a 4 here, okay? They go together. Then I put in my multiplying sign, and now I'm going to handle this trinomial. 2 times negative 4 is negative 8. Would 2 multiply to give you negative 8 and combine to give you positive 7? It'd be 8 and negative 1. So x plus 8 and x minus 1. Leading coefficient is a 2, so divide both terms by 2. And now I can come over here and reduce. So 8 divided by 2 is 4. And 1/2 does not reduce, so I push the 2 up. 2x minus 1. Done with the numerator on the second fraction. The denominator. 2 times 2 is 4. What multiplies to equal 4 and combines to equal a negative 5? That'd be x minus 4 and x minus 1. Don't forget about the leading coefficient being different than a 1. This reduces to negative 2, and since this fraction does not reduce, we push the 2 up. We've just completed step 1, factoring. That's the toughest, tedious part. Now we're going to identify the excluded values. Now I'm going to show all of my work, but after this problem, we're going to start doing it just in our head. So here's what we do. We take each one of these factors here, each one of these parentheses, and we're going to set it equal to 0. So x plus 4, I set it equal to 0 and I solve. That means that x cannot equal negative 4. That's an excluded value. Then I take x subtract 2, I set it equal to 0. It means x cannot equal 2. And 2x minus 1 set it equal to 0. And it means x cannot equal 1/2. Because if x equals negative 4, we have 0 in the denominator. Can't do that. Breaking in math rule. Same for 2 and for 1/2. So I've done step 1, 2, and now step 3 is just canceling out. Remember, when we cancel things out, they don't just magically disappear. They really turn into a 1. So x plus 4, is there any factors of x plus 4 on top? There is. Cancel it out. You can only cancel 1 for 1. You can cancel anything on the bottom with the same identical thing on top. Do we have any x subtract 2's? We do. Cancel and cancel. And 2x minus 1, cancel and cancel. Remember, really, what do these turn into then? 1. So 1 times 1 times 1 is, and 1 times 1 times 1 is 1. Okay, on top we're left with the 6x minus 5, and that is our simplified rational expression. I'm going to draw a little line here separating these two problems. We're going to move on right now to number 8. Okay, so this problem is like number 1 that we started off with today. We're going to factor by grouping. So I'm going to start by looking at the 8 and 12. The largest number I can divide out of both is a 4. So I'm going to take out a 4 and I can take out 2 x's. I can take a 4 out, divide a 4 out, and 2 x's. I'm left with an x plus 3. I'm going to copy and paste that and put a little question mark in front. What plus x is oh, and I think I may have forgot something here. I forgot a 2, didn't I? 4 times 2 is 8, x to the third, 4 times 3 is 12, and x squared. Okay. So 2x times what is negative 18x? The answer is negative 9. Let's make sure we did that right. Is negative 9 times positive 3 negative 27? Yes. Both the front and the back have that parentheses 2x plus 3. What's in front of the first parenthesis? 4x squared. What's in front of the second parenthesis? Negative 9. Now this breaks apart because they're both perfect squares, subtraction, and we have an x squared, and a 2x plus 3 and 2x minus 3. That's the numerator. So I'm going to write that really small. It's 2x plus 3, 2x minus 3, and 2x plus 3. The denominator, what multiplies to equal negative 30 and combines to give you 13. 1 and 30, no. 2 and 15 work. So x plus 15 and x minus 2. Leading coefficient is a 10. I'm going to reduce those fractions. 5 goes into 15 and into 10. And 2 goes into itself and also into 10. Now, when I write it up here, remember we're going to push that bottom number up. 2x plus 3 and 5x minus 1. I've just completed right now the factoring portion, okay? Now we need to look into, is that easier to see? Okay, now we need to look into excluded values, but this time we're going to do it in your head. By the way, there's no problem with you writing it down on paper. So in your head, I'm taking 2x plus 3 and I'm setting it equal to 0. What's the first step you would do if you're going to solve for x? subtract 3. And the next step would be to divide by 2. That's your first excluded value. Okay, let's take 5x minus 1, set it equal to 0. What's the first step? Add 1. The next step is divide by 5. There's no problem with you actually writing it down on paper and solving as well. So I've done step 1, factoring. I've done step 2, excluded values. Now I'm going to cancel. You can only cancel one thing on the bottom with one thing on top. And I say that because, do you see how there's two groups of 2x plus 3? And there's only one on the bottom? So it's common for students to want to go, I'm going to cancel all of them. You can only cancel one on the bottom with one on top. Since there's no 5x plus 1 on the top, I'm done. 2x minus 3, 2x plus 3 over 5x minus 1. Don't FOIL it out. This problem is done. Okay, let's go down right now. I'm going to fold this. Please go down to the next problem. Okay, so this numerator, the first, I see a 6 and a 12. I just don't want there to be, give me 1 second, I think this will help. Okay, so in this numerator position, I can divide each by a 6. I can also take out an x squared. What goes in the parentheses? Well, 6 times 1 is 6. I need 3 x's, so I attach one more. And 6x squared times negative 2 would be negative 12x squared. I've factored out a 6x squared in the first, in the numerator of the first parenthesis. Okay, let's move on to the denominator. Now I'm going to go over here and show my work off to the side. What two numbers multiply to give you a negative 4 and combine to give you a negative 3? Multiply to give you a negative 4, combine to give you a negative 3. Anybody? Negative 4 and 1, okay. So I'm going to do it over here, just way off to the side here. So negative 4 and positive 1. Negative 4 and positive 1. Okay, don't forget we have a 2, so divide both by 2. Okay, now I'm going to come over here, and 4 divided by 2 is 2. And the 1/2 doesn't reduce, so we push the 2 up. 2x plus 1. I don't want that to get confused with anything else. I'll just cross it out. When dividing fractions, there's 2 steps. 1, turn division into multiplication. And 2, we're going to take the second fraction and we're going to flip it. So what's on bottom goes on top and vice versa. So notice this is like the example I gave. Wherever the 2x goes, the 1 must accompany it. It's not just 2x and then a plus sign and then a 1. They go together. So this was on the bottom, it now goes to the top. There's nothing I can factor out. It's done. And what was on top in the numerator goes to the denominator. So 12 and 24. I can factor out a 12, and I can take out a maximum of 3 x's. What are we left with? Well, we need to attach one more x to come up with 12x to the 4th, plus a 2 to get 24x cubed. We've completed step number 1, and step number 1 is to factor. Step 2, let's identify the excluded values. If we set this equal to 0 and we solved, our first excluded value would be positive 2. You add 2 to the opposite side. If we set 2x plus 1 equal to 0 and we solved, we would subtract 1 and divide by 2. I'm going to come back to this part in just a second. Let's do the last one. If we took x plus 2, we set it equal to 0 and we solved, we'd come up with a negative 2. Now, if we took 12x cubed, well, a number by itself does not somehow result in excluded value. This is the portion we're looking at. And so ask yourself, what is the only number that you can take times itself 3 times and you still end up with 0? So it's like 2 times 2 times 2, 0? No. Is 1 times 1 times 1, 0? What's the only number? 0. So I've completed step number 2. Step number 3 says, what can we cancel? So I have an x minus 2 on the bottom, and I have an x minus 2 on top. I have a 2x plus 1 on the bottom and a 2x plus 1 on top. There is no x plus 2, but here's the part you've learned how to do that looks a little bit tricky. There's a 6 on top and a 12 on the bottom, and although I can't just cancel them out, I can reduce them. 6 divides into itself 1 time. 6 divided by 6 is 1. And 6 divides into 12 2 times. Now, you learned freshman year, and you may have forgot, how do we reduce when we have variables that are the same on top and bottom. So I see an x squared on top and an x cubed on the bottom. So I'm going to show you just like this. X squared is on top, and x cubed is on the bottom. So I can cancel 1 for 1. Where am I coming up with this again? Here's x squared, and here's x cubed. So cancel 1x on top with 1 on the bottom. 1x on top and 1x on the bottom, and you're left with 1x on the bottom. So I'm going to change this into a 1, and I'm going to eliminate that x on top. Remember, when we eliminate them, it doesn't just magically go away. What do these actually turn into? So 1 times 1 times 1 times 1 is 1. On the bottom, 1 times 1 times 2 is 2. There's 1x and an x plus 2. That is our final answer. Okay, our last problem of the day. It looks like the simplest, but in reality, it was more difficult for most students. So if you recall, whenever you're adding or subtracting fractions, you always need a common denominator. Think of this right here as some couple, right? Wherever x squared is, you have to have that negative 9. They go together no matter what. But this is a single 9. This 9 is all by itself. It has nothing with it. So when we find a common denominator, let's put parentheses around this because they go together. This single 9 is not the same as this 9 because this 9 is really, it belongs to the x squared minus 9. It belongs to that quantity. So this is missing a 9. Let's go times 9. Whatever we do to the bottom, we go times 9. Right now I'm in the process of finding a common denominator. On the right-hand side, we are missing an x squared minus 9. An x squared minus 9. So at this time, both sides have a 9 and an x squared minus 9. So let's write that down. 9 and x squared minus 9. So I have found a common denominator. Now I'm going to examine the numerator. 9 times 3 is 27. And then I get to take this negative sign. Don't forget it's negative. Negative 2 times x squared. And negative 2 times negative 9. Let's combine like terms in the numerator. 27 and 18 is 45. And I can't divide here by negative 2. It's not going to make it any prettier, so I've factored as far as I can. I'm done with step number 1. Now step 2. Remember, a number by itself is not going to result in excluded values. But let's look at this part. There's a couple ways to do this. One way is I'm going to show you 2 different ways. One way is you could recognize that this is the same as x plus 3 and x minus 3. And knowing that, what are the excluded values? X cannot equal negative 3, and x cannot equal positive 3. Now, maybe it's possible that that did not spring into your mind. And if that's the case, we can go x squared minus 9, and we'll set it equal to 0. Our excluded values will only be real numbers, not imaginary. We're going to add 9 to the opposite side. We're going to take the square root, recognizing we'll have 2 answers, plus or minus, and the square root of 9 is 3. So my answers would be exclude negative 3 and exclude positive 3. You can think of it like this, or you can set this equal to 0 and solve. Either way, you'll get the correct excluded values. So I've done step 1, step 2. There's nothing I can cancel out. Step 3 is done for us.